Good morning, girls. Children, in chapter Quadrilaterals, we had started with the exercise 8.2 yesterday, and I had explained you the midpoint theorem, that is day before yesterday. Yesterday I explained exercise 8.2 question number 1 and question number 2. So I hope you have seen both these videos, and today I will continue the exercise with question number 3, and let's see how many I can finish. Now, question number 3. Do you remember what is a midpoint theorem? The midpoint theorem says that if a line segment joining the two midpoints of the two sides of the triangle is parallel to the third side and is equal to half of it. Okay, so coming to question number 3, it says that ABCD is a rectangle. So let us draw the figure. ABCD is a rectangle. You know what is a rectangle? Opposite sides in a rectangle are equal and each angle is a right angle. Now ABCD is a rectangle in which P, Q, R and S are the midpoints. Now when we join these midpoints, we will get a quadrilateral. Fine. Now this quadrilateral, you have to prove that PQRS is a rhombus. And you know what is a rhombus? Rhombus means all the four sides are equal. So let us first see what is given. In the given statement, you're going to write ABCD is a rectangle. Yes, in which AB is equal to CD and AD is equal to BC. Fine. You also know that angle A is equal to angle B is equal to C is equal to D is equal to 90 degree. So this is given, and also P, Q, R and S are the midpoints of the given respective sides. Okay, now you have to prove that PQRS is a rhombus. Now to prove that this is a rhombus, we have to first prove that PQRS is a parallelogram, because rhombus is a special type of a parallelogram. Now, for this we have a construction. We'll join AC. Yeah. So write construction. Join what? AC. Now we'll apply the midpoint theorem. Now children, what I'm giving you a small homework in this question, that you will first prove that PQRS is a parallelogram. How? It will be the same procedure what we have done in question number 1 and question number 2. Twice I have explained you. So, after joining AC, you know that S and R are the two midpoints. These two midpoints will be parallel to AC. This line segment will be parallel to AC. And similarly, PQ, because P and Q are also the midpoints, so PQ will also be parallel to AC. Now when PQ is parallel to AC and SR is parallel to AC, that means SR is parallel to PQ. Fine. So when PQ is equal to SR. Now you also know that SR will be half of AC according to the midpoint theorem. Go through that theorem. PQ will also be half of AC. So therefore these two sides will be equal and parallel. So therefore PQRS will be a parallelogram. So this complete proof you are going to write in the beginning. Okay, so your proof will be, your homework is till you will see my previous video and you will write PQRS is a parallelogram. And to prove PQRS is a parallelogram, we have to apply the midpoint theorem. And that complete proof you will see in my yesterday's video, and apply the same procedure for this question also. After this, the whole method procedure I am explaining you here. So did you follow what I said? I hope yes. Now, PQRS is a parallelogram. Now since PQRS is a parallelogram, you know that we have already proved that PQ is equal to SR. So we can now write PS is equal to QR, and PS is also parallel to QR. Why? Because it is a parallelogram. So we write opposite sides are equal and parallel. Now these are very general things, children, so you will write it yourself. Now, as I told you that we have to prove that PQRS is a rhombus. To prove that PQRS is a rhombus, if we somehow prove that the adjacent sides are equal, then it will be a rhombus. So now we have to consider two triangles in such a way that we prove them to be congruent, and after proving them to be congruent, these corresponding parts will be equal. Okay, so I can take triangle PBQ and triangle QCR. You know why? Because if I consider these two triangles, I will be able to cover up PQ and QR. Or if I want, I can take PQ or PBQ with this one also. Triangle APS. So any two adjacent sides, if you prove them to be equal, we will get that PQRS is a rhombus. Okay. So I hope this explanation of mine is clear to you. We now come to in triangle. Let us take PBQ, in triangle PBQ and triangle. Let us take QCR. Okay, QCR. How will we prove them to be congruent? We know that this angle is equal to this angle. Okay, so we can write angle B is equal to angle C 90 degree, since ABCD is a rectangle. Okay, now when ABCD is a rectangle, each angle is a 90 degree, that is a right angle. Now, can I say that PB is equal to CR? PB is equal to CR. Do you know why? Because we know that AB is equal to CD and half of AB will be equal to half of CD. Fine. Then, can I say BQ is equal to CQ? Yes. Why? Because Q is a midpoint. So, now you understood that these two sides and angle is same as these two sides and angle. So, therefore, triangle PBQ is congruent to triangle what? QCR by SAS criterion. Now, when the two triangles, children, are congruent, we know that the corresponding parts are equal. So, therefore, PQ is equal to QR. Okay, now, okay, so let us name it as 1. Let us name this equation, this one, as 1, okay, this as 2. Now, we also know that PQ is equal to SR. Yes, because opposite sides of the parallelogram are equal. Now, if I compare PQ is equal to QR, okay, we also know that QR is equal to PS. Now, compare all the three, or we can say in combining, when we combine these three, we write combining all the three equations, we know PQ is equal to QR, QR is equal to PS, and what? PQ is also equal to SR. So therefore, when all the four sides of the quadrilateral are equal, therefore PQRS is a rhombus. So I hope it is clear to you that this completes the proof that PQRS is a rhombus. We first prove PQRS to be a parallelogram by applying the midpoint theorem, and for that you will see my yesterday's video. Complete that part. After applying the midpoint theorem, we will write PS is equal to QR and PS is parallel to QR. Then these two triangles you will take and prove them to be congruent, because we need adjacent sides to be equal. So by SAS, these two triangles are congruent. These sides are corresponding parts, so we write CPCT here. And when we compare these three equations, we get PQ equal to QR QR equal to PS, and we also know that PQ is equal to SR. So therefore all the four sides are equal in a quadrilateral, in a parallelogram, therefore PQRS is a rhombus. So I hope this is clear to you, because simple proof this is. Now we have the next question. ABCD is a trapezium. Okay. Now ABCD is a trapezium in which AB is parallel to DC. So in all these questions, children, we have to apply the midpoint theorem, and or maybe in some questions the converse of the midpoint theorem. Now coming to question number 4. Question 4 says that ABCD is a trapezium in which AB is parallel to DC. BD is a diagonal and E is a point of AD, is a point midpoint of AD. A line is drawn through E parallel to AB intersecting BC at F. Figure is given. I'll draw it. You have to prove that F is a midpoint of BC. So let us see the diagram. That ABCD, you know, in a trapezium, one pair of opposite sides is parallel. So let us draw this figure. It's given in the book. So we have this trapezium in which A, B, C, D. So you know that obviously AB will be parallel to CD. There is they have joined the diagonal BD, and there is a line segment, which this is a line segment, not line segment, line. A line which is passing through the midpoint of AD, that is E. Okay. So this is given, and this point is F. So this is the diagram figure given. Given points are AB is parallel to CD. Why? Because ABCD is a trapezium. Then E is a midpoint. E is the midpoint of AD. Right? And what else? The line, this EF, is parallel to AB. 1 minute. Yes. And show that, to prove, we have to prove that F is the midpoint of BC. Now for this, children, we have to consider a point which is the intersecting point. Let us take this point to be G. Okay, let us take this point to be G. Okay, and let's start with the proof. As I told you, children, that it depends on the question whether we have to apply the midpoint theorem or the converse of the midpoint theorem. Now we know that E is a midpoint. We also know that EG is, we know that EF is parallel to AB. So therefore EG will be parallel to AB. Now when EG will be parallel to AB, E is a midpoint, therefore G will be the midpoint of BD according to the converse of the midpoint theorem. So I will write proof. Starting with, we write in triangle, let us take triangle DAB. Yes, we will write E is the midpoint of AD, yes, and EF is parallel to AB, therefore EG will be parallel to AB as G lies on EF. Yes, now EG is parallel to AB, E is a midpoint, therefore by the converse of the midpoint theorem. Okay, children, if you have not seen my video, please go through it, then only you will understand these questions. So therefore G is the midpoint of what? This BD. Okay, now G is a midpoint of BD, we have proved. We actually have to prove that F is a midpoint of BC. Now next point, you know that EF is parallel to AB. Yes, we also know that AB is parallel to CD. Now can I say by 1 and 2 that EF is parallel to CD? Okay, now therefore when EF is parallel to CD, that means GF is parallel to CD. You will write G lies on EF. Yeah, clear? Now, when we apply the midpoint theorem in this, the converse of the midpoint theorem in this, right, in triangle BCD, find GF is parallel to CD, yeah, and G is the midpoint of DB. We have just proved above, we can write proved. Therefore what? Now GF is parallel to CD. Out of GF, 1 is a midpoint. So therefore, according to the converse of the midpoint theorem, F will be the midpoint of BC. So therefore, by the converse of the midpoint theorem, we write, let me write here. By the converse of the midpoint theorem, we write F is the midpoint of AC. Okay, so this is what we had to prove and hence complete, hence proved. So children, what we've done, we know that the diagram complete figure is given. We only take a point G here, which is not mentioned in the diagram. Now, because E is a midpoint and EF is parallel to AB, G lies on EF, so EG will be parallel to AB. Now EG is parallel to AB, E is a midpoint, therefore by the converse of the midpoint theorem, G becomes a midpoint of BD. The same we apply for the triangle, this one, BCD, that GF is parallel to CD. How is GF parallel to CD? Because EF is parallel to AB, okay, and AB is parallel to CD, therefore GF is parallel to CD, as G is lying on EF, as I told you here. Now, according to the converse of the midpoint theorem, children, you know that if G is a midpoint, F will also be the midpoint of BC, and that completes not AC, BC. Now, that completes the proof, and you will solve today question number 3 and question number 4. Okay, so learn the theorem statements, practice them and solve these 4 questions, 1, 2, 3 and 4, and tomorrow I will explain you next 3 questions. I think there are only 3 more questions left, and that will be completing the exercise. And you keep practicing them, and if you have any doubt, children, you can ask me. Okay, but see that you complete your work on time. Okay, thank you. Have a good day.